This is a schematic of our overall circuit. We have the two thermistors on the left, the top one being our reference for the room, and the bottom one being our system one, which we will heat up and cool down with the incandescent bulb and the fan. This resistor helps just make the circuit work, and the 1K up here is controlling the sensitivity between the two thermistors and the 741. We put the output of that into LabJack and put it into LabVIEW and have it compared to whatever limits we want on our range. And the output goes to the transistor to either turn on or off the incandescent bulb, and also sends information to the NXT to turn on or off the fan.
Here's our block diagram, LabVIEW block diagram. We have the analog input from LabJack. It's a differential input so that you get better resolution at lower voltages. We have the case structure for the NXT motor, whether it's above the range or below the range.
How do you attach iPipe on your email?
Here's our circuit. We have the reference thermistor here,
It might look really bad.
and over here we have the system thermistor. Underneath is the incandescent bulb, and next to it is our fan. The bulb is connected to the
Transistor to turn it on or off depending on the voltage read in LabVIEW. And now we're going to run the circuit.
So the light turns on to heat up the thermistor, and you can see the relative voltage.
Relative temperature represented as voltage in LabVIEW.
It's increasing as the thermistor heats up. And here you can see our sliders for the range that we want it in.
And as it continues to heat up, once it reaches a certain temperature, the light will turn off, and then actually it'll start flashing, and then it will turn off completely. And as it continues to heat up from residual heat, the fan will turn on.
Key safety features. So we learned, one of the main things we learned for the circuitry was we were originally trying to use another 741 as a comparator.
But that caused a lot of issues with trying to figure out how to power it and what actually needed to go in and how it all worked. So we decided to try to use a transistor because you can actually use those as switches, which we had forgotten from taking electronics last year. So once we introduced the transistor, everything went a lot more smoothly.
Also learned quite a bit about LabVIEW, getting timing and case structures correct, as well as the differential inputs. Took some browsing of the LabVIEW, LabJack forums actually, to figure out how to work